in Fabric, right? And let me just, while I'm presenting this, I'm going to go ahead and also introduce myself for those of you who don't haven't met before. So my name is Nellie Gustafsson, and I lead the data science and AI work inside of Fabric. So, and I hope that you can now see my screen. Yes. So I lead the PM team basically, who drives a lot of our, all of our data science features and many of our foundational AI capabilities. Now, with that said, there are AI capabilities across all workloads, and Fabric is a big team, so we all also collaborate together. And today I wanted to talk to you about, well, our AI roadmap, but I also have incorporated some data science pieces in here because I really want everyone to also know about how you can basically enrich data and get insights from data, whether you're using machine learning or whether you're using generative AI. So that was my plan to do. And if you have questions at any point, feel free to, stop me, raise your hand. I'll try to pause for questions throughout our session. All right.
Sorry for
So,
interrupting, Ali. I beg your pardon. Actually, before the meetup, I'm making form and sent to registered users.
mhm.
They have already asked some questions, and during the session, I will be sharing this question with you. So sorry for interrupting you.
Okay, no worries. All right, thank you. So let's get started with data science, right? And I want you to think of this, what you're seeing here, as in like, sure, I mean, we're talking data science in this session, but a lot of these steps that you take for solving, answering questions, and getting insights from data are actually very similar, regardless of what you're doing, let's say here in the middle part, right? You always need to have an idea of what questions you want to answer. And these questions often arise when your users are looking at their business data, kind of getting insights, but also questions around like, hey, why is this way, or how can we address this issue? Why are these customers, they seem to be churning, for example? Why is that? And once you've done that, there's always, whether you're an analyst, whether you're a data scientist, a data engineer, you always need to essentially be able to tap into the data, discover it, analyze it, maybe even pre-process it before you can solve a certain problem or answer a certain question. Uh, so in Fabric, we do want to make this whole process a lot more seamless, especially when it comes to these handoffs between, let's say, business users to analysts, data scientists, and others. So really think of this end-to-end workflow that you're seeing here as a way where you can basically replace the middle part really with anything. It's just that in this case, we're going to do that question and do the discovery of the data and pre-process it for the purpose of building machine learning models that can then enrich the data and give us new insights, like predict insights about our data, right? So in Fabric, we have lots of different experiences where you can use lake houses, as you see here. You can use notebooks to author code, and then you can leverage models and experiments inside of Fabric to be able to track your experimentations that you're doing in the notebooks, right? With lots of different tools that I'm going to also cover around using low-code tools for this, right? So if you're new to this area, don't worry. We really intend in Fabric to offer experiences that can make it very easy to get started. But once you have, let's say in this case, let's say I did my experimentation, I have my models, then there are various different ways in which you can enrich your data. This is all centered around using Spark, Python, and notebooks today, right? So those will be the primary tools that you would be using. But again, you can use a lakehouse or really any data that you can reach from within a lakehouse. So of course, you can use shortcuts, but also mirror data, because ultimately when we mirror data sources inside of Fabric, it essentially is represented as delta tables. So it really opens up the opportunities for what data you can enrich and process and analyze. But enrichment also happens inside of Fabric. It's through notebooks today. In general availability today, we have the models and experiments, the lake houses, the notebooks, the environments, and all of those building blocks that are needed but we also support batch scoring. So we're also going to cover that today. But we also have some exciting things. So I'll start with what we have in market, but also sprinkle in some of the new things that are coming. And thanks to direct lake mode, it basically means that once you have your predictions, one way you can serve them would be to write them back in one lake and serve them into Power BI, for example, leveraging direct lake mode, right, inside of Fabric. So this is why we believe that we can really bridge the different gaps that exist typically if you have a separate ML platform from your BI and analytics platform. So that's really like a place where I do think that Fabric is truly differentiating. And let's talk a little bit more about how Fabric differentiates in this area by diving into different features. So one feature that I hope that this community is familiar with is semantic link, right? So semantic link actually started off as a way to bridge and allow data science practitioners and Python practitioners to be able to tap into the semantic layer. But once we started to do this, we just noticed a lot of excitement for scenarios that are not just related to ML around semantic link, right? So semantic link you can think of essentially as a Python SDK for the semantic layer. That's how you should think about it. And semantic link, as I mentioned, is a way to tap into the data. It helps data scientists to be able to tap into the same source of truth that the business users are seeing. But most importantly, in the last year, we've actually focused a lot of our efforts on semantic link on being able to automate a lot of BI engineering workflows, because BI engineers just gotten super excited about the possibility to use Python to not only troubleshoot and validate the data in the semantic layer, but also be able to leverage that for testing, do automated testing on this, leveraging notebooks and Python. And very recently, and I don't have a demo of that, so maybe we could do a follow-up and bring Emily from the Power BI team to present that topic, would be around that where we added templates so for best practice analyzer, Vertipack analyzer templates, where you can actually start off in a semantic model, and you can get these templates in a notebook to be able to analyze and validate your semantic data set or semantic model. So lots of exciting things and scenarios that semantic link as a library enables inside of Fabric. And today you can use semantic link only in Fabric. That is one of the differentiators that I wanted to call out. And there is also the semantic link labs library, which is very related, that you may have heard of, which essentially is where we add some of the newest innovation to get a sense of what resonates. And when you guys, the community finds that there are certain functionality in semantic link labs that you like, what we do is that we harden it, we make it GA ready, and we put it in the actual semantic link library in the product. So that's why there exists this duality between these. It's just a way for us to move a lot faster and do a lot of these things. And Micah Kowalski is doing an amazing job, not only launching and founding, being the creator of the semantic link labs library, but also kind of constantly keeping up with the efforts. And our engineering team is working alongside Michael to be able to support on these requests. All right. So semantic link is a big piece. And if I go back to this picture, think of semantic link as a piece that really helps here, as in like, well, how can I get the access to the semantic layer from the lakehouse and the notebooks? So just wanted to call that out as well. All right. So if you get to the next step where you need to explore the data, you need to prep the data, maybe the data that you're tapping into from the semantic layer, you need to combine data from different sources. And some of these sources may actually be raw sources where you need to clean up that data. How do you do that? Well, in a notebook, you can pretty much do anything, right? If you know how to author code. And it's not always like, we don't take for granted that every user in Fabric is a hardcore Python developer, right? It's actually something that we want to get more and more users familiar with, to say that, hey, Python is a super powerful language. It can allow you to transform your data really in all the ways possible. So in order to make this easier, we also have Data Wrangler as a tool, which is a visual tool inside of the notebook that gives you essentially a canvas to be able to do data exploration, preparation, cleansing directly from Python without knowing Python, right? So Data Wrangler is a really interesting tool where you can basically open up a data frame, you see here, and there are also some new experiences in Data Wrangler where you basically open up your data frame in this grid view, where you get a visual overview of your data frame, Python data frame. It also supports PySpark data frames, by the way, and you can then get started and work on this. So I'm going to go ahead and I'm going to show a demo of this, but now I also realize that I don't know if you're going to be able to hear the audio of this demo. So maybe I have to share it in a certain way, I suppose. Let me see. I'm sorry, I haven't really used Zoom a lot before, so I'm going to see.
Just share if we don't hear the voice, and I will try to help. Just share and let's see.
Yeah, okay, yeah, because I didn't. Oh, yeah, you know what? I think I will have to share with sound. So I'll try to share again and see if can you see my screen?
Um,
See a slide that says demo.
Okay, cool. You see the slide. Awesome.
Yeah.
Okay, cool. Thanks. All right. So let's get started with the demo. And this is going to show you Data Wrangler, basically. All right. And let me know if you can't see my screen, because in Teams, I know which screen is shared, but this one I can't see.
we see your screen.
Get some new AI-powered capabilities in Data Wrangler. This is a code-generating tool in Fabric notebooks that helps you transform your data in an immersive interface. If you haven't used it before, we have a new Getting Started experience to load in sample data. You can then open Data Wrangler from our table display or from the notebook ribbon, whether you're working on a Pandas data frame or a Spark data frame. You can also configure custom sampling behavior for larger data sets. In this demo, let's take a closer look at the classic Titanic dataset. Data Wrangler gives us a customizable dynamic display with built-in visualizations for every column. We also have summary statistics displayed in a dedicated pane that updates as you select columns. Lastly, there's a library of common data cleaning operations grouped by category. If you don't know where to get started, a new set of automated suggestions will analyze your data with rule-based AI and highlight the most relevant operations for you. In this case, we might want to drop the passenger ID column, which looks like an index. We get a live preview of the code and an updated display preview, and then we can apply or discard that step. Next, let's scroll over to the age column, which has some missing values. Data Wrangler is suggesting that we fill them in using the average value, which I'm going to go ahead and do. Once again, we get a preview with the display and with code before we apply or discard that step. The last suggestion is to split up the names values so that we have separate columns for first names, last names, and titles. That looks right, so I'm going to accept the step. I want to hold on to the last names, which will help me group passengers into families, but I think I can drop that first name column. I'll get a preview and I'll apply the step. Then I'll close out my suggestions, and for clarity, I'll rename this new column to title, which is what it contains. If you need an operation that you don't see in Data Wrangler, you can now use Copilot to generate custom logic. Here, I'll use the new title column to derive a gender column based on each passenger's honorific, Mr., Mrs., etc. As with any Data Wrangler operation, I can get a preview before applying or discarding that step. This code and the result look mostly right, but I'm seeing some unknown or missing values. If I scroll back to my title column, I'll notice that I didn't account for rarer values like Dawn, which should be male, so I'll update my Copilot request and regenerate new code. There we go. I can preview that again, and the result looks even better. In Data Wrangler, every step I apply is saved to a running list that can be expanded and revisited, with the option to undo the most recent step. At any point, I can copy all that code to a clipboard, save the updated data as a CSV, or export it to my notebook. If I've been working on Spark data, the code will be translated from Pandas to PySpark automatically. The end result is one reusable function that combines my logic. With Fabric, transforming and prepping data can be that easy.
All right. So that was a demo of Data Wrangler, right? So it's a tool, and you don't have to obviously, like, everything that I show here is not necessarily like you can apply Data Wrangler for non-data science use cases, obviously, right? Because this is something where you, even if you have any type of data, you just want to analyze it, just clean it up a little bit. I really recommend using Data Wrangler in the notebooks. It also gets you familiar with the Python code or PySpark code that it generates. All right, so moving on, if you remember that kind of end-to-end life cycle, once we've kind of prepped our data, we can then engage in that inner loop for machine learning, which is very iterative. And it's also around like being able to experiment and essentially build an ML model. So for this, we do have features to help ease building machine learning models and tracking those experiments. So what you see here essentially is an example of our ML flow experiences, where you can actually go ahead and start experiment runs, create models and experiments, which become items in your workspace. You get the full lineage of these. You can manage permissions, etc. But you can also then, as a data scientist, track your experiments and runs. This is something that data scientists do in many machine learning platforms. And something that Fabric also has as a native capability to allow this tracking and tracking these experiment runs and metrics, as well as the models. Once you, let's say, have a run that you're happy with, then you can go ahead and make that a model. And now that ML model that you're getting is the one that you would invoke to get the predictions, right? So we have both support for both ML flow models and experiments. But sometimes users tell us that, I don't know how to use ML flow. I may be a seasoned data scientist, but I really have never used the ML flow concept to be able to log my metrics. Well, then no problem, because we also have, as you see here, auto logging, which means that even if you're, let's say you copy a snippet of training code from a website, you just want to learn how to do ML, and you're using scikit-learn, which is a very popular library. If you copy paste that code snippet and run it inside a notebook, even if you don't know how to invoke it with ML flow to create that experiment artifact in the workspace, we actually do auto logging for you. So that you don't even have to worry about logging the metrics and the models. It would just automatically be done for you in the notebook itself. So these are ways where we can make it easier to leverage these features. And then you can save at the model once you're happy with it in your workspace, essentially, in your ML flow registry, essentially, which is your workspace in that case. And then you can use that model in notebooks to run batch scoring and more. And we're going to get to that as well. I wanted to pause here to see if there were any questions. I think I saw some questions in the chat and just wanted to make sure that I can also leave time for that.
As I mentioned earlier, I have gathered a lot of questions. So taking at an opportunity while you are talking, I'm just copying and pasting this question there. Actually, I have pasted for question. If you don't mind, you can read beginning from the first one, and you can go on just answer to the questions. The first one is, as artificial intelligence powered analytics platforms become more autonomous, how
Yeah.
do you see the role of data scientists evolving? Will their responsibilities shift more toward system oversight and less on model building? Maybe my pronunciation is not good, so you can read it also yourself. This is our first question.
Yeah, I mean, this is a great question, right? Because like we see AI models being able to do a lot more sophisticated things. There are agents that basically can do tasks that can do train machine learning models and analyze data in very sophisticated ways. And I think that this kind of I would really like, the way that I view it is really that machine learning tools, just like a human can use ML tools to achieve things and get insights, AI tools, agents can also use ML as a tool to derive those insights. But what we see, however, is that there, in more and more cases where even if you have an autonomous agent that is doing certain things, there always needs to be a human in the loop that can actually understand and scrutinize what the agent did. Because in many ways, AI and Gen AI models are non-deterministic, which means that, it's very hard. Like sometimes, they hallucinate. Sometimes, there are things that need to be kind of fact checked, right? And that's where, I would say that the expertise of knowing how to use these tools and how they can, and then to be able to inspect how the AI was using these tools, and if the AI actually drew the correct conclusions, is going to be crucial. So I think that, like, as in many other areas, yes, AI will automate certain tasks, but I think that also only allows humans and people who are in the roles of data scientists, data engineers, others, to be able to perhaps focus more in those cases on making sure that that is the correct plan, that the AI executed things in the right way, right? And maybe instruct the AI if it didn't execute the right plan to say, you know what, I don't think you should use this type of model, use this type of model. It's actually better. So from that perspective, there's always going to be a human in the loop. But yes, I think what is different is that we're going to be able to automate many more tasks, even with machine learning as well, and have the AI essentially maybe do a lot of the exploration on its own, maybe even go ahead and say, hey, go and clean this data set for me and tell me why you cleaned it in a certain way, why you removed certain things, and have the AI also like explain what it's doing along the way. But I don't know if that answers the question, but I definitely see ML as a tool for AI. That's how we are thinking about it as well.
Thank you
And this is
very much
also
for your answer. Yeah, so sorry for interrupting you. The next question is, what are some challenges organizations face when integrating AI into analytics? How does Microsoft Fabric address these challenges? This is our second question.
Yeah, this is a great question. And maybe I'll save this for when we get to the AI section as well, because what Fabric generally does, like, I mean, we've done this for ML as well, you see here, right? We have built-in capabilities inside of Fabric to also ease that integration so that you don't have to integrate and stitch together many different disparate platforms, right? We actually do the same thing for AI. Like for Gen AI features, Fabric has a built-in AI endpoint. And for features like Copilot, obviously we use it, but we also use it for some other features that I'm going to cover next, which are more related to how you can use AI from code. So basically, wherever you use AI in Fabric, you can always choose to use the built-in capabilities, which means that you actually don't have to spin up an Azure resource if you don't want to, right? And this helps a lot of customers in the sense that it just helps integrating AI into analytics because it is built in.
Great. And if you don't mind, I can go on with the question. There are 4 questions. You have already answered to 2 of them. The third one is, what metrics or KPIs should organizations use to evaluate the effectiveness of Fabric's AI-driven analytics solutions?
What metrics to use? Yeah, I mean, for any capability, I would really say, I mean, I'm leaving Copilot out of this, right? I mean, Copilot, I feel like that's up to each individual developer if you feel like Copilot can help you. But for many of our experiences, like including data agent or AI functions, or essentially a lot of these experiences where you build with AI, just like you see here in the screen, we have machine learning experiment tracking with ML flow. So there actually have a lot of similarities between ML and AI. So why do we have this? Why do we have ML flow? It's because we're evaluating the results of a machine learning model in this case to tell us, is this good enough? Does this meet our bar, right? But for example, if you're using AI, it's a very similar principle. So if you're using a Gen AI feature model, like a GPT model, yes, it's true that we didn't actually build the model ourselves. That's something that was done by OpenAI or Azure OpenAI. But this in the same way, MLflow actually also allows you to evaluate the outcome from LLMs, right? So I do think that, like, highlighting on this piece is that you will define the metrics. Ultimately, you need to define to say that, well, I'm asking the AI model to translate something here, right? And you want to measure the accuracy of the translation, which would be your metric. But you also have to have a ground truth data set. You have to have a source of truth that you can actually benchmark this against, right? So I would really say that a lot of people are kind of get the impression that sometimes using AI is magic, and it really isn't. It is a model. It is non-deterministic. It needs to be evaluated. It will hallucinate. It will be wrong, right? And that's why it's so important that you always have evaluation frameworks that can do this. Now, in Fabric, ML Flow is integrated today for ML models. And we are, in the coming weeks, also releasing some notebooks that can help you to evaluate your AI experiences. So for example, when you're using data agent and things that I will cover next.
If you don't mind, we can leave, the fourth question to the end, so I can ask at the end of this because it's very general, and really, I look forward to hearing your answer for this question. So you can go on with your presentation. Thank you.
Let's do that. And I think I'm going to like fast forward a little bit, so I'm going to skip some sections here, but ultimately, like I wanted to highlight where we've added new capabilities, right? Because I showed you like you saw Data Wrangler, which kind of comes in, somewhere in between here, in between these steps. And I also kind of recovered ML flow and experimentation and modeling. And you can do all of that from notebooks. But what is new in Fabric, right? In the past months, when it comes to being able to enrich your data? Well, we have introduced automated machine learning. So just know that this is there. This can help you, just like Data Wrangler can help you to prep and clean your data. With automated machine learning, you can get faster to baseline models, right? And this is, again, these are all tools that AI can use as well, right? It just happens. I wanted to highlight the things that are built into Fabric. All right. When it comes to model deployment and data enrichment, which is like when you have that, let's say you use AutoML, you trained your model, but now you want to use that model to enrich and predict your data. So how can you do that? Well, today you can do that with batch prediction. You just basically write a script, you invoke a predict function, it's going to run it. But what's new when it comes to data enrichment? Well, you can enrich data in different ways. So one is when you have batches of data. This could be millions of rows, thousands of rows that you need to essentially enrich. And then you add a column. Maybe you add the predicted column of like, will this customer churn, yes or no? Or, what is my sales forecast going to be for this product in the next week? And then you add the predicted values, right? But you add them essentially in the data set in one lake, right? So you're writing it back to a table. That's batch. But in some cases, you need a more swift, more real-time way to understand, was this transaction fraudulent or not? And you can't really wait overnight to have a batch job running, enrich the data, and then show those predictions in the report the next morning. You may just need that instant answer, right? So we're super excited that to soon have a public preview. This is now in private preview of a real-time model scoring endpoints in Fabric. And this means that inside the model item that you see here, you'll be able to actually go into the model that you've trained your ML model and go and activate an endpoint. It's really like a one-click thing. And you don't have to worry about the underlying container infrastructure to host this model. You don't have to worry about the exposing the model in an endpoint from whatever container infrastructure that you have. All of that is taken care of for you. And you even have an interactive way to even test out, send it a JSON or just use this UI to autofill and test the prediction right away to go and see the endpoint. And once you have the endpoint, you can now invoke this as a REST API from any of your applications. So you can build the model inside of Fabric on top of the Fabric data, create one of these endpoints, and now have your applications invoke it, right? So this is an exciting capability. It will be public preview soon. And so stay tuned for this one. It is currently in private preview. All right. Now, we're talking about data enrichment, right? Model scoring, model predictions. That's all great, right? And we talked about data science and all of this. But how does this kind of shift when we're talking about AI, right? Let's talk about how you can build with Gen AI in Fabric, right? So now if you notice, this picture has changed slightly. We used to have model and experimentation here. Now we have prompt engineering, right? Because we're going to talk about how Gen AI kind of changes this picture. And my main point around this is that a lot stays the same, if you notice, right? You still need to have a pretty robust way to do data discovery, data preprocessing, data engineering. I would even argue that data engineering is going to be more important than ever. Because when you're using Copilot or agents or AI to get insights on your data or enrich your data, more users are going to discover flaws in your data. So if you had quality issues in your data, more users are going to see that, right? It's because AI kind of exposes that. So I would really say that, thanks to generative AI, I think data engineering is actually going to be even more crucial to do and make sure that you have a good quality data set. Because as Arun Ulag says, right, if you have garbage in, you're going to get garbage out. So if you think about the whole holistically, this end-to-end workflow, the inner loop kind of changed to prompt engineering, because when you're working with AI machine learning models, you're building the model yourself. And of course, you can build custom models yourself. You can actually train LLMs yourself, but they're far from, everyone can do that because you need massive resources. And what we're also seeing in the market is that prompt engineering is actually very powerful. And what is prompt engineering then? Well, prompt engineering essentially is a way to prompt a pre-built generative AI model to do tasks that you are requiring of it. And as you may know, generative AI models are general purpose models. They can do many, many different things. And the programming language to interact with a generative AI model is natural language. So English, for example, or maybe, Turkish or some other language, right? So basically, prompt engineering is a way to use natural language as a programming language to be able to get the AI model to do what you want. And for this, you also need to experiment. You also need to test and evaluate because, you will be surprised. Sometimes telling an AI model something in capitalized letters and bold versus, just not using capital letters and bold actually makes a difference. Using different words actually makes a difference. And this is how you need to kind of test and evaluate what is the best prompt for a specific situation, right? But there's more than prompts that go into prompt engineering. We'll cover that in a little bit. So, but before we do, as we were on the theme of, inference, scoring, getting real-time insights from ML models, how do you do that with AI models? Because when you're invoking an AI model to get a result, let's say I'm sending a question to an AI model and I'm getting a result back. What I'm doing is inference. It's just a different type of model. And you may have a fraud detection model, machine learning model, and you're invoking it to get the prediction of whether this is fraud or not. That's also inference. So that's why I'm highlighting this part of the diagram to show you that you can do inference in Fabric with some of the new capabilities that we've added. So before we dive into this piece, prompt engineering and how you can construct and get the AI to do exactly what you want, let's talk about inference using AI functions. So let's talk about AI functions. What are AI functions? So, there are many tasks that you may want to solve as part of your data engineering workflows, right? Data enrichment workflows. And the truth is that generative AI models are actually helping to do many of these tasks that traditionally you may have used ML models for in the past, right? But also other tasks. So AI functions actually are a set of predefined functions to solve very specific tasks, where you can do inference and get very specific results. But we also allow AI functions to do more generic tasks, right? So let's talk about this a little bit, right? So let me first jump to the list of the different AI functions that we have today, right? So imagine that you have a one-line syntax in your Spark or Python notebook where you can do things like, hey, I want to find the similarity between two columns. Let's say I have two text columns and I want to see, are they talking roughly about the same things? What's the similarity score? We have an AI function for that. Let's say that I want to classify. I want to say that, hey, I have these product reviews. It's just a bunch of text. And I don't have a product category column. And you can ask the generative AI model, in this case, using this function to say, can you classify, read through all of these product reviews and go and classify to me the product category and use these three categories: toys, beauty products, or books, for example. And it can then have the generative AI model process this data frame row by row and add the classification column. So we've added all of these different tasks like analyze sentiment, extract phrases, fix grammar, summarize, translate. And these are super common tasks, right? And you can apply them, today, this is public preview. You can use that in a notebook on F64 and above for now, but we are lowering the limit on April 30th to F2 and above. So you'll be able to use these Gen AI features on F2 and above from 30th of April. But, again, your task may not be in this list, right? So how can we make it super easy for you to do inference on top of anything, right? So with AI functions, we also allow that. So actually you see that here. So here you see the syntax of what it can look like. So what I have here is a data frame called df. All I'm doing here is to say that, hey, I want a column category, and I want you to map the address to the corresponding country and put it in category, right? Or put it in country. I mean, I'm sorry, this is wrong. So imagine that I've added the country address. I have an address, it's text. I can now extract and put the country, for example, for this address on the first street, and I can have the LLM use its general knowledge about where this address sits to find me the country, for example. So this is a simple example that I wanted to show. But before we dive deeper into the AI pieces, let's look at the demo of what these AI functions look like and how you can do inference inside of notebooks as a data engineer.
In this demo, imagine I'm working on a data set of airline passenger feedback. My teammates put data into a lakehouse and cleaned up some of the CSVs as tables, but they left one of those CSVs to me. Let's see how native AI capabilities in Fabric can help me drill in deeper. First, I'll create a new notebook that's automatically attached to my lakehouse. From there, I can read in files and tables as pandas or Spark data frames with just a few clicks. Let's take a closer look at those customer reviews. My data frame has information about the review author's country of origin, the date of those reviews, and more, plus the text content of the reviews themselves. People are pretty opinionated about air travel, so there's a lot to analyze here. With Fabric, we can take advantage of built-in machine learning and Gen AI capabilities to enrich this data instantly. A new AI Tools tab in my Notebook ribbon lets me open up Data Wrangler, or train a new model, or get Copilot help from the chat pane. With the recently released set of AI functions in Fabric, I can also apply LLM transformations directly to my data. Here's our documentation to learn more. There are 8 AI functions, and they work on pandas or Spark data frames, with one-line syntax so simple that you won't need docs for long. Back in our notebook, we can also generate code by selecting an input data frame and column. Here, I'm going to apply the sentiment analysis AI function to the column of airline reviews in my data frame. We'll insert that code right into our notebook and run it. You'll recall that some reviews were positive and others were less so. The LLM-generated output from my AI function reflects that range, and our interactive notebook display shows the distribution of sentiment labels if we scroll over. We'll see that there are positive values, negative values, and neutral and mixed values. Here's that distribution. Now let's do something a bit more complex. From the catalog of AI functions, I'm selecting Use a Custom Prompt. I can ask the Fabric LLM to draft responses to the author of each review and personalize them based on the text content. For bonus points, I'm specifying that the responses should be drafted in the native language of the author's country of origin. I'll copy that dynamically updated code into a new cell in my notebook. Then I'll hit Run, and the AI function will attempt to generate responses based on my custom prompt and on each row of input data. Now, our original data frame had a column containing the country of origin for each passenger. That should be what determines the language of the AI function's response if everything goes right. Let's give it a moment and then take a look. Some of our passengers were from Germany, others were from France, and others were from Turkey. If we scroll over to our custom responses, sure enough, we'll see responses in German, French, and Turkish. I could keep going with other AI functions, but for now, let's get this enriched data back to my team. I need Copilot's help writing my data frame to my lakehouse. In addition to the chat interface, I can now access Copilot directly from any code cell for a more seamless developer experience. Here, I'm asking for code that converts my pandas data frame into a Spark data frame and then saves it as a new table called airline. We'll hit send and give Copilot a moment to process. The output will be custom code. And once it comes back and I accept it, I could even get Copilot to explain, optimize, or document that code with a new set of quick actions. For now, I'm going to delete this import statement, plus some commented lines, and then save that enriched data to my lakehouse. Back in my lakehouse, I'll refresh my tables, and there's my enriched airline feedback. It's ready for my team to act on, enrich further, or visualize. With Fabric, Gen AI fits in seamlessly.
All right. So, yes, so on the theme of Gen AI, so you saw AI functions in action. You can use that as part of your data engineering workflow. So if you already use PySpark or Python and you're using Pandas, for example, data frames or PySpark data frames, this is definitely something that you can do to process it. But again, we are going to launch a set of evaluation notebooks as well to kind of show you how you can evaluate the results from these functions and to kind of give you an example. And I really want to highlight that, all of this work, it is a code features. I do encourage you to run evaluations on it, right? To make sure that it fits your use cases and it meets the bar that you have set. And in order to do so, it's good if you start thinking of, do I have a ground truth data set? Like, do I have, let's say, a data set with the perfect translations in this case, where I can essentially compare the AI's result against that and get a similarity score for that, for example. So in many ways, you can basically say that these type of functions can also help you to get your data ready for other AI scenarios, right? Because there's oftentimes, like these actions that you may need to take to not just up the quality of the data, but also to add additional details, to just also make it easier for agents that are processing the data later on to be able to, achieve better results, right? So making your data LLM ready or AI ready is a big piece, and you can use AI to make it AI ready, right? So that's kind of how at least I think about it. All right, now, last but not least, I wanted to spend the last 10 minutes on talking about agents. This is actually one of our biggest investment areas on AI in Fabric. You may have heard about data agents. This is something that last week at the Fabric conference, we announced that we're renamed AI skills to data agents. So what is a data agent inside of Fabric? Well, it is a conversational agent that essentially today helps to get insights about data, right? So, but this is something that you have to create, curate, and configure, right? So if you compare this with Copilot, Copilot is also an agent, you can think of it, right? But Copilot is something that where Microsoft is essentially doing the prompt engineering and the configuration to get the agent to do what we want it to do, help with certain tasks. In this case, you can build your own agent that can, for example, answer questions about domains that you are knowledgeable about on the data. And this will offload you from answering all of those questions. You're basically building your own expert and making sure that this expert has the knowledge that you want it to have, right? That's what it's about. So today in public preview, we do have Lakehouse, Warehouse, Semantic Model, and Event House KQL database as sources. So we've added multi-data source support in this agent. You can then add context and configurations and then publish this agent. And today, if you publish this agent, well, this is actually slightly old. We didn't show Foundry here, and I have a slide on that later. You'll see that you can use it inside of Fabric. You can share it with someone else, but you can also use it in private preview with Copilot Studio that then takes this agent, exposes it in Teams, which is super cool. Or in public preview that we announced last week was that you can also now use it in AI Foundry to build another agent that is using your data agent as the expert tool or like as a knowledge source for that. All right. So let's take a look at a demo of data agents to give you a sense of what this experience looks like and what you can do with it. So this is one I'm going to walk through here. So we are in a Fabric workspace, right? And we're going to go ahead and create a data agent. So this is the item that used to be called AI skill. So you can basically go in, create a new item, just like you create any other item, and then go and search for data agent. And you're going to be able to find it here, right? And once you start with this experience, it's going to take you to that experience that allows you to configure this agent. But before we do, we're going to go ahead and give it a name. So we're going to go ahead and give it the name of a customer expert, because this is our expert on customers, right? So this is what we want to use. So once we do this, now I landed as a creator of this agent. I landed in this creation experience, right? And the first thing I do, since it's a data agent, is to add a data source, right? And here, this is where what is new, I would say, in the past month, where we've added support for multiple sources. So you can see here that I can mix and match from semantic models, KQL databases, lakehouses, warehouses. But I'm going to go ahead and I'm going to go and select a semantic model as my first source. This is a very small semantic model, but I want to use it because it contains my customer loyalty data. So this model contains everything about my loyalty customers, but also general customer details that I have. So I'm going to go ahead and select both the tables in my semantic model, and I'm going to ask a question. For example, who are the top 5 loyalty customers, right? I didn't do any configs yet besides adding the source, right? And you can see that I can get a list of customers. Well, that's great, but how did the agent derive at this answer? I kind of want that transparency, right? So here we can see that it issued this DAX query, and it actually picked the total lifetime customer value, which was, I believe, the right measure to use in this case to get the answer on. So that was great. So if you have great names of columns, you can kind of get a lot of good results. Now let's add another source. Let's add a lakehouse. And this lakehouse had many more tables. So I'm going to go ahead and scope it down because I want this expert to know about customers, products, and sales, right? So once I do the schema selection here, this is what my agent will be knowing about, right? So it will ignore the other tables. But before I do anything, since I have 2 sources now, I also want to add some instructions for my agent to tell it where to go to find what type of data. And this is just like you have like a new team member, and you would explain to the new team member where to go to find certain data, right? It's very similar. And then I can start asking another test question. So I'm going to ask, what else can you tell me about these customers? All right. And in this case, the agent has to figure out based on the instructions where to go to get the customer details. And I can see here that I'm getting a lot of good customer details, like lots of details, but I want to see how the agent got this. And I wanted it in this case to go against the lakehouse because that has the latest up-to-date customer data. But here I see a DAX query. So it actually went against the semantic model, which isn't completely wrong, but the latest data was in the lakehouse. So other tools I have to guide my agents on how to answer questions is to use example queries or verified answers. So I know for a fact that I want my agent to go against the lakehouse. I know exactly which columns I want, which tables it should go against. So I can add a question here, and I can add the exact query that I want the agent to use for this type of question. So if I go ahead and ask, what else can you tell me about these customers again? It's not the same question I had in the query, but it's similar enough, right? So my agent should be able to figure out, as it did here, to go and use my example query. And here you can see that it actually went and used the example query because I see a T-SQL statement here versus the DAX statement we saw before, right? For those customers. All right. So in this way, I can basically go and iterate and build my agent. And every time someone issues a query to my agent, just know that the security layer, the security rules like RLS, CLS, all of that will be honored because we always pass through the asking user's identity. So you don't have to set up extra security to guard your data. We honor the same security rules. And here I have the same agent. I just evolved it. I worked an entire week. I'm telling you, it's the truth, and struggled to get this agent to do what I wanted. But once you kind of figure out how to do the prompt engineering in the right way, it's really magical. So here you can see that I have a much richer set of instructions. I'm instructing it to use the delivery data set, my KQL source that you see there. I have a third source here. And I also have a lot more example queries. Here I have my KQL example questions. And now I can ask more sophisticated questions because this agent knows more. I can ask for my Diamond Status loyalty customers that had late deliveries, and I wanted to break it down per customer name. Now, in this case, the agent has to use all my instructions, all my example queries to figure out how to solve this, answer this question. If we give it some time to execute, we're going to see that, well, we got the list of the customers. So far, I mean, it has a late delivery. Seem to understand our question correctly. But if we look at what steps it took, this is the interesting part, right? Our agent had to first go to the semantic model and get the Diamond Status loyalty customers and get their names because it needs the names to be able to query and get the right customer key from the lakehouse, because the customer keys between the semantic model and the lakehouse actually didn't match. They're not the same types of keys. So, and then once it used the names to get the keys, it then used those customer keys to go to the delivery data set that contains late delivery information to be able to query to get those late deliveries. So in this step, the agent actually took 3 different steps across 3 different sources and essentially did an AI level join, right? Got answers from one to join with another thing. And I could have done this manually, but it would have just taken me much longer, right? So let's end with an even more sophisticated question, right? To show that the agent not only uses the query tools to retrieve the answers from the databases, but also can do reasoning and synthesize the data on top of that. So here, I wanted to know about this agent to say, hey, you know what? categorize the reasons for these late deliveries for me and identify the couriers that frequently had these deliveries, because I need to have a chat with them, right? If they constantly kind of missing their delivery deadlines. And you can see that it gave us the categories, and it also can give us the query that originally gave it the late delivery reasons or delivery notes that it analyzed. Now, once I'm happy with my agent, I can go ahead and publish my agent, and I can then use my agent across various different experiences. I can share it inside of Fabric, but most recently, we actually added our public preview integration with AI Foundry, which means that you can now build agents in AI Foundry that can maybe combine and use unstructured data using AI search, and you can then use the data agent as a tool for the other agent. And this is a pattern you're going to see a lot more on across Microsoft stack and in the tech industry, that you use many different agents and you kind of layer them and they use each other as tools. So this is starting this pattern. It's very exciting, and this allows you to achieve more things, layering this data agent with other agents that can take actions and other things outside of Fabric. So I'm going to end here because we are short on time, and I did have a lot of content. So I'm going to stop here for maybe taking one question before we end.
Only one question. We have.
Yeah, I mean, I guess since we're almost out of time, but yeah.
Okay, actually, if you have time, but we have 15 minutes. If you have time, okay, I can ask for question. If not, then let's go on with the question.
I actually think I have another meeting.
Okay, got it. So let me ask the.
Got canceled. Yeah, it seems like my meeting got canceled. So yeah, I can stay.
Okay, please. I'm very happy that you have canceled.
Yeah.
So, so we have for question. So let me begin with the fifth one. What advancements in AI technology do you foresee as crucial for analytics in the next 5 years, and how does Microsoft Fabric position itself to lead this transformation? I love this question. So
Yeah. I mean, I would generally say that it's like, I don't think anyone in the world can predict what's going to happen in 5 years right now, given how fast we're evolving and how fast we're working, essentially how everything is evolving in the space. I definitely do think that we're going to see a lot more on agents. That there's a reason that you hear Microsoft and Google and everyone talking about agents, which is essentially like the industry is quickly deriving at certain standards and standard ways in which that agents can interact with each other, where you can add tools to agents, etc. So I think that you're going to see a lot more of multi-agent collaboration going forward, where you can basically build solutions where you can build agents that are experts and good at very specific things. And this is where the data agent really fits in, because to say that, hey, how can we empower all the data professionals using Fabric to be able to construct and build these agents that can then contribute and be part of bigger solutions, agentic solutions, right, across your organization. We think that this is crucial, and it's crucial to get essentially all of you empowered with the tools that you need to be able to provide that value that a data platform like Fabric, analytics platform like Fabric can offer, right, as your organization is building these agentic solutions. So I'll kind of leave it at that, but it's very, very hard to say, where are we going to end up in these, the models are going to get better, hopefully cheaper, right? And we're going to see a lot more use cases where autonomous agents or agents can basically collaborate and talk to each other to solve certain tasks.
Okay, thank you. Last two question. What kind of industries or sectors have benefited the most from Fabric's AI tools so far? Something different. I'm in question.
I would say that we have, at FabCon, we had some use cases from to a partner and a customer. I wouldn't say that there are certain industries specifically. We have customers across every single industry in Fabric, and we're seeing wide adoption across all the industries. I wouldn't say that anything really stands out. I'm actually super excited that we also have customers in industries that typically deal with sensitive data, like healthcare, others who are actually progressing really well, leveraging AI. And you're going to see much more security and governance over time also on AI features. As we harden these AI experiences, as the more of these AI experiences that enter general availability, you're going to see that we don't treat it separately just because it's AI. We try to have one layer of security, one layer of governance, and that should apply to AI as well, right? AI is just another workload, if you will, that is leveraging the data in Fabric. So I don't see any specific pattern there all over the industries.
Got it. Thank you. And last question, Vasim asks, how sentiments are get assigned or identified for each response?
Oh, in the AI functions, how the sentiments gets assigned. So the large language model has been, so there's a bunch of prompt engineering that's happened. So the functions come essentially pre-built. So there's a lot of work that went in to get the LLM to provide a certain sentiment score, right? And the LLM is essentially generating sentiment scores that then get translated into, and for example, to say, yeah, this is a positive sentiment, this is a negative sentiment. But you can also use the generic function if, let's say, if you want to have this very specific thing where you want to even the LLM to return a sentiment score itself, not necessarily the yes or no, etc. You can actually use the generic AI function to prompt it to provide the results that you need, right? But it's ultimately underlying, it's using a sentiment score. And I think this is typically how these models work, is that you would give it essentially to say that, hey, if positive is 100 and negative is like basically like more closer to 0, give me the score of where this falls in between, right? And it would give you maybe to say, hey, it's 97, which means that it would be more positive than negative.
That was the last question. Thank you very much for your time, for your wonderful presentation. With your permission, first of all, I would like to go on to end the stream on YouTube. So
thank you so much for joining, everyone. I really appreciated your time. And I know this was a lot of content. So if you're interested in